this is Annie. Actually, I've known Annie for about one and a half years, and ever since she has always been very excited for the opportunity to join the SCELSE community. Annie has been trained at MIT, and she has always been interested in microbiome research, and you know how close from SCELSE heart microbiome is. But Annie is a computational biologist, which means that she can actually develop a omics-based framework that is exploiting nowadays the huge amount of information that is available and is actually poorly exploited. So here we are, joining forces as a computational microbiologist.
Yes.
Hi. And please stay tuned and look forward for the good work that will bring this synergy and collaboration.
Definitely the people here, I really love the community here at SCELSE with diverse expertise, and everyone is highly collaborative and interactive. During my postdoc, I was collaborating with SMART and AOS, and so I visited Singapore many times and established this close connection with SCELSE and with Alan. And last year, during a conference at Boston, I met Jan and Rebecca, and they told me a lot about the research and culture here at SCELSE, and which greatly motivated me to join. So our long-term aim is to develop bacteria-based therapy, which is to use engineered bacteria to cure diseases such as cancer. And currently our lab is going to build AI models to predict protein binding to ligands and protein binding to DNA in microbes. And SCELSE is a great community for microbial research. For example, our models can help SCELSE researchers to better understand the behavior of their microbes, to understand the mechanism in their microbes in terms of how they respond to different environments, interacting with another organism, or regulating themselves. And also, research here at SCELSE can help us optimize our models, in which forms this healthy feedback loop that with better models, we can better understand microbial behavior, which generate better data and knowledge to train better models. Generally, our lab's expertise is bioinformatics, AI, and microbiome. Specifically, we're developing AI models powered by biological knowledge. So we're not trying to only build a bigger model or train it with more training data, but instead we want to supervise our model with biological principles and develop a new AI algorithm that works better with biological data such as protein and DNA sequences. Definitely bacteria-based therapy. We want to engineer bacteria to cure diseases such as cancer. We know that many bacteria prefer to accumulate and grow in tumor environments. So we can engineer the bacteria to better sense the tumor environments and then release anti-cancer drugs or activate immune response only in tumor environments. However, we don't know very well how bacteria sense different environments or regulate different genes, but fundamentally it's a problem of predicting bacterial proteins binding to environmental molecules or ligands and bacterial proteins binding to different DNA sequences. And that's what we're trying to do, is to develop AI models to predict this process. So another crazy idea we have is to use engineered bacteria to control diabetes. We want to engineer our gut microbiome to accumulate sugar when there's a high sugar level in the gut and slowly release it when there's low sugar level in the gut. So after 10 years, we want to build a team at the intersection of academia, industry, and education. The first part of the team will work on developing new AI algorithms. And for industry, we want to work closely with pharmaceutical companies and clinicians. And the last part, we want to focus on education of data science. Handpan is a great musical instrument for relaxing and expressing myself.